So welcome everyone to our third webinar week in the Rutronik Connects webinar series. In this week, we are currently speaking about ultra-wideband, LoRa, and other fitting technologies in this case. And today's webinar will be with Enocean, suitable IoT for healthy and green buildings. So my name is Thorsten Killinger, and I'm Corporate Product Manager here at Rutronik. Currently working with Rutronik since 5 years. Here with me today I have Markus Florian, Chief Commercial Officer from Enocean, and Cal Shadam, Sales VP in EMEA, also from Enocean. Both of them will guide you to today's presentation. Here are some short practicalities. The duration of the webinar will be about 1 hour. Questions are encouraged. You can set them into the Q&A on the bottom tab. Also, the recording will be, or there will be a recording of the webinar and also of the slides. The slides will be presented to you afterwards. And with this, I don't have any further information, so I welcome Markus Florian and Cal Shadam. Hi, Markus. Hi, Cal.
Morning. Hi, Thorsten.
Morning. Hi. So
Morning, everyone.
I will just hand over to you, Markus. You will have the first presentation, and then Cal, you will have the second, and afterwards we will go into the Q&A.
Okay, very good. Okay, then I will share my screen with the slides. Okay, presentation. Okay, good.
Yeah.
Okay,
now we see it.
It looks also different than myself. Okay, thank you for checking. So again, sorry for the inconvenience. Again, thank you, Thorsten, for giving the opportunity that we can present our company and our products. As mentioned in the introduction, my name is Markus Florian. I run the sales organization in Enocean. I'm now with the company more than 10 years. Maybe just briefly, my background is originally also from the semiconductor industry. So I worked with various companies, big companies, global companies, but also startups, always in the context of wireless communication, ultra low power consumption. So that was always the context. What we will be doing here today is giving you an overview about the products and technologies we have in our portfolio. I will be starting with the Enocean energy harvesting products, which we also call Enocean Classics. And then I will hand over to Cal, who will give you an overview and introduction on the Edge product category. So let me give you some introduction. So we will, of course, a little bit explain how this works, energy harvesting. So what is this, we call it secret sauce of our technology, which differentiates us from many other, or most of the other solutions in the sensor environment. And what is important about it? Energy harvesting for sustainable IoT, that is also the title of this presentation. I also wanted to give you an understanding. So in our world, basically, there is 2 Enocean entities. This is why I also wanted a little bit to describe it to avoid any confusion. So there is Enocean GmbH, where Cal and I are from. So we are the technology provider, have been founded over 20 years ago. And we provide energy harvesting components in the form of modules, but sometimes also like finished products. And we have already been able to ship tens of millions of products into the market together with our partners, which are many renowned OEMs. And we do have in our own organization a global presence. Headquarter is in Munich, near to Munich, but we do have the team across the world, and of course work with partners like Rutronik to have a global presence. Our products, we support 3 different protocols, radio protocols. There's on one side the sub-gigahertz solution, which is also called the Enocean protocol, which was originally invented by Enocean, but has been had transitioned over to an open standard, which I describe shortly. So there's an open standard in sub-gigahertz where you use, for example, 868 in Europe, or 902 in the US, or 928 in Japan and Australia. But we also have added support for Bluetooth, low energy, and Zigbee. So these 3 protocols we can support maybe brief answer why, because these three protocols are suitable to be operated in an energy harvesting environment. And that's the main reason. And that's, of course, that's what we are driving ourselves for innovation. Then, as mentioned, there is also the InOcean Alliance. That is an independent organization from us. It carries the name InOcean, that's true, but we are simply a member in the InOcean Alliance as the other over 400 member companies as well. The mission of the InOcean Alliance is to create a standardization, to create open documents which everybody can read and see, to create an ecosystem of solutions. There is, as mentioned, over 400 companies in the alliance, and over 1 million buildings have been installed worldwide and equipped with this technology already. In total, these 400 member companies will represent about 5,000 different products. You can also find them on their website. There's a database where people can search and look for products from the various OEM partners which are using our technology. And as mentioned, they're aiming and doing proactively promoting the technology, but also making sure that there's a standardization and interoperability, which is also a differentiation of this technology towards other solutions. The benefits, of course, we will dive into a little bit, is of course cost reduction, because of course you can save wiring. So wireless provides you more flexibility. It's sustainable because, of course, we are not in a need of batteries. So they might be looking cheap at the first moment, but of course, what it is, it's not sustainable because, of course, they contain material which is not sustainable. And then, of course, they can get empty. So you need to be replacing them and you add an additional maintenance effort. All this together, of course, is allowing us, and then we will describe a little bit, to save energy by the use of this technology in the various products by creating sensors, which then transmit a signal into gateways or receivers or relays in order to process this data and then communicate or monitor, control, heat, ventilation, light. All this is, of course, all the aspects of a building automation system can be covered with this approach. On the next one, yeah. So what is, of course, energy harvesting? A little bit an insight. This is basically the secret ingredient, which we have various possibilities to use the energy from the surrounding. There's kinetic energy, which is, of course, the one, let's say, which is the most famous one, where the company InOcean has been starting with. At the beginning, it was piezo, but that has been replaced about 10 years ago with an electrodynamic generator, which we produce together with a partner and is being used, for example, in switches and also window handles. Another methodology of generating energy from the environment is solar, is light, of course. So in that case, you use solar cells. And what's very important is the energy you accumulate during the day, for example, is being accumulated and stored, and for example, in a supercap, in order to allow you also to operate the sensor in a dark environment, for example, at night, or also in a building when there's a weekend, maybe shades are closed and it continues to work. Thermal energy uses the delta of a temperature. This is being used, for example, for heating valves. This is the so-called Peltier element, Seebeck effect, which you may know from your cooling box when you do camping. Only here you reverse that effect. If you apply a delta of a temperature to this element, to this Peltier element, then it generates energy, electricity. And also in this case, this electricity is being stored in order to generate or create products which are maintenance free. And the fourth possibility is a magnetic field. There's an example of one of our partners. It's so-called CT clamps. Basically, the magnetic field, which is generated by the current going through the cable, is used to operate that device. And you can, for example, monitor energy consumption with this. Now, there's a single phase or a triple phase CT clamp. It's very common or very often used also, for example, in industrial environment to monitor the consumption of machinery. So this is the overview now, product overview about what we have in the portfolio and what had been basically also updated in the last couple of months. There's one which was a very important effect was the transition from Eco 200, which is this electrodynamic generator, over to Eco 260. At the first sight, when you look at the picture on the left, there's not much difference, which is on purpose. Because what we did is basically we used the product, which was very, very good, and improved it on various aspects, but of course continued to guarantee compatibility to the existing and the previous generation. The main reason also was what we do have here is know-how in the production facility of producing such a device. And the first generation production facility was basically coming to its end of life, which on one side is also good because it shows you that the product is very successfully being produced and sold. But again, at a certain point, it requires to have renovation, and that's what we did. This project has been completed last year already. We have introduced the Eco 260 together with partners. We use this, of course, in our switch modules, which I show you later, but there's, of course, customers who buy this in a pair from us together with a transmitter for their own products, and all these have now basically converted to this Eco 260. The benefit, again, is that we have now secured availability of this product with a completely new production line, fully automated, and this gives us the flexibility, cost advantage, and also the capacity to cover large volume demands with this new approach. Here you see also what I mentioned before. Besides us using the Eco 200 in our switch module, there is the possibility to combine the Eco with a transmitter module if you or your customer wants to generate his own design outside of the traditional switch specification. Then you have on the left side the combination of PTM 535 with the Eco 260, which allows you to cover sub gigahertz radio standards in this combination. And the other alternative is combining the Eco 260 together with the PTM 535 BZ, which allows you to generate either a Bluetooth or a Zigbee signal, and it's configurable by an NFC interface. Here are a few examples just to give you an idea why this might be useful for. If somebody combines the combination of an Eco with a PTM 535, there is various applications which can be covered. There is door handles, window handles, foot switch. There is key card switches. There's even bus stop buttons, which, for example, is one of our key customers already using very successfully. There's even a leakage sensor being developed, and there's probably many, many more ideas which are not listed here. And that is, of course, due to the possibility to combine this together, these two devices. Here an overview about the so-called PTM 215. That's our switch module. In this switch module, we have integrated, of course, the Eco as a Kinetic harvester together with a transmitter. And this is a form factor which is very commonly used by the various switch manufacturers around the world. They use this for their switches so that you can cover the various aspects of a switch design, which we all know is different in Germany than it is in the US, than it is in Japan or in Italy or in France. So this is let's say the engine, if you want so, and our partners, our switch partners, are developing their plastics around it so that from the outside it looks like a traditional switch. Also here we support the 3 different radio protocols, so sub-gigahertz in ocean protocol, Bluetooth in the form of the 216B, and then also Zigbee in 2 flavors, 215ZE and 216Z. What we added also here is NFC configuration possibilities. So you can, for example, change it from encrypted to unencrypted. So you have some options there. And specifically for Bluetooth, what we have been able to do is by migrating to a new platform, we have increased the output power. It was always okay also before, but here also to give more safety margin. So there's more output power for longer range also in this case. Another product is our motion sensor, EMDC. This collects the energy from a solar cell, as you can see. So this is a movement sensor. So this is the IR lens. And here next to it, you see the light level sensor. So this can be used for traditional movement detection, and of course also stores the energy to operate at night. And what we also have added with this product is a so-called activity monitoring. You can change by using the NFC interface between a traditional motion detection and activity counting. Activity counting basically is used for creating heat maps, as is shown here in this picture. Basically, what the sensor does, it can detect if there's a lot or little or medium activity, and that is as information enough to allow, for example, in the retail space, to understand how people and visitors are flowing around in the given space. It's not so much about counting actual people, but measuring activity. So, and this is also, we have integrated this into this our product, and it's in production since mid of this year. And I forgot about, of course, that's also available sub-gigahertz and Bluetooth at the moment. Then here we have the multi-sensor, which is called the STM550. This integrates 5 sensor functions. It's operated again by solar, and also again stores this energy to operate at night. So the sensor function included are temperature, humidity, light level, magnet contact to monitor if something is open and closed, and acceleration. So it has included a 3-axis acceleration sensors, which, for example, among many other use cases, can be used in smart desking to identify if a desk is being occupied or not, because via the NFC interface, you can optimize the sensibility of the sensor, of the acceleration sensor, and detect if there's little movement or more movement. Others is, of course, tracking and tracing. And there's many more also, like for HVAC and lighting controls and so on. So this is a product also in production since mid of this year already. Then, of course, very important is, and that's what we have added recently, we announced that in September, is a new product generation on the TCM side. So this is for the receiver, for the line power side, because of course all the signals you generate, you want also to receive. So this is TCM 600, TCM 615. The 600 is a programmable one. You can use the internal CPU core, which is a Cortex M33, with up to 512K of flash. And the 615 is basically, if you want, kind of a modem function. So you control the 615 via an external MCU. And with that, you can obtain connectivity to the ocean world. Typical applications is, of course, receivers, relay receivers, flush-mounted receivers, but also gateways of all kinds. And we have samples of the 615 basically now and go into production beginning of next year. And the 600 is planned for sampling beginning of next year, and then we'll go in production mid of next year. So these are the 2 new elements we have added just recently in the portfolio. Here, just briefly an outlook, and also Cal will dive a little bit into connectivity and edge. You might have also read that we have this cooperation with Aruba, the wireless access points. The idea behind that is that you use the wireless access points found in office buildings, for example, or in hospitals. Equip those Wi-Fi access points with a USB dongle, which we provide, and make them ready for receiving in ocean data for the building automation concept. The benefit is here you can use the existing infrastructure generated by the Wi-Fi access points and combine that with sensor data which is coming from the building to optimize, again, usage, to optimize heating, to optimize light. And the benefit is, of course, using an ocean radio protocol, which is 868, that you have a much longer range. So the moment you have secured Wi-Fi coverage with an access point, you are pretty sure that you have already the same, or actually better coverage for sub-gigahertz radio. So this is then combined. So you enter this USB stick into a Aruba access point. It's being converted with a program which we call IoT connector, which transfers this into MQTT and then submitted into the cloud to be, for example, monitored and used in a dashboard. If you then need additional connectivity because of the range is not enough or because there are special requirements, then of course there's the option, and Cal will go into details, to use a smart server from us, which gives you the connectivity, both of course to the wireless world, but also to the building management system, to the BMS. Yeah, and let me now just a few examples, application examples where the technology can be used. Yes, we have talked a little bit already about smart desking. And of course, it's all about benefits, both ecological and monetary. And then we have done some calculations and also have been able to verify this in so-called proof of concepts, where the savings for a desk, the cost per annum is about 8,000 euros. And if you then optimize the usage, both in physical usage, but also in heating and lighting, there is a potential of saving about 30% of the desks. No? So if you then, of course, count this into a larger entity, but also in companies which have 100, 200, or 1,000 people, that reflects quite a substantial effort, which gives you an immediate return of investment in really short time. The calculation we have made, for example, up there, if a company with 10,000 employees, they have an annual savings, if you implement this concept, of 24 million. So to do that, of course, as mentioned, there is the sensors, for example, the multi-sensors we mentioned, where you can monitor the desk utilization. You can basically not only book it, but also monitor if it's really being used, no, and avoid that there is bookings which are not being really physically being used. And that can again be done with NFC configuration. Also important is all the data governance requirements are covered, because of course this sensor can only detect that somebody's there, but not who it is. No? So that's also an important topic. Another aspect is, of course, air quality, ventilation. It's all known since, of course, COVID, that, of course, you want to make sure that ventilation is being done. It's for the health, but also for the well-being. And also there, by implementing this concept, of course, you increase productivity. There have been some studies that by good air, you can increase this by 50%. Vice versa, if you have bad air, then the productivity can decrease quite dramatically. I think you have also all heard about the studies. Also, if you sit in a room with, I don't know, 10 people and there's no ventilation, by the time the meeting goes on and on, there's so much CO2, which compares nearly to having 1 or 2 glasses of beer. No? So the concentration and the well-being also, of course, is being lost. You can do that by measuring CO2, temperature, humidity, and also, of course, this is possible with solar-powered sensors, which then transmit this data to a receiving device. Another example is, of course, energy savings. This is also the benefit of using wireless technology, also gives it the advantage that you can very quickly retrofit it. And compared even to other aspects of insulation or changing installation, this is simple and very cost efficient. And also in this case, the combination of smart heating together with room occupancy and smart desking can save energy up to 26%. And also there immediately gives a very quick return on investment. And then, last but not least, a few examples where this has been installed. There's, as you can see, big buildings, office buildings, small buildings, in private homes. One of the most famous examples is the Square in Frankfurt, next to the Frankfurt airport. That's a building which is nearly 1 kilometer long. And in that building, there is nearly 20,000 Ocean nodes being installed. And that's on the other extreme side, if you want, so there is here the company Weber House, which creates prefab homes, specifically in the German-speaking market. And also there, they are using technology via one of our partners to equip all the newly built houses with Ocean technology for heating control, for lighting control, shading control. And also there, the advantage is that it's flexible, that it can be adapted to the live conditions, and it can be enhanced at a later point if needed. That brings me to the end of my presentation, and I will be handing over to Cal.
Thanks, Marcus. Let me just share my screen. Okay. Thanks for that. So my name's Cal Shadam. I'm the head of sales for Ocean across EMEA. I've been with Ocean for 2 years, and that was due to an acquisition that Ocean made back in October 22, where they acquired a business unit out of Renesas. My background is I've got over 15 years of experience within the let's say, building automation, smart building space, spending times at various sort of smaller startups, and also having some time within the corporate world like Honeywell, also Dialog and Renesas. I'm going to talk to you about our smart server product, which allows and helps people to integrate lots of different sort of systems within a building. So first of all, if we take an existing building, as you can see from the image on the left hand side, you normally have lots of different sort of systems from HVAC systems, lighting, fire and life safety systems, security, systems, etc. And all of these systems have traditionally been installed in silos independently of one another. There's very little sort of interoperability between the different systems. And this causes a challenge when it comes to looking at how a building is really used in order to get that visibility and that granularity and create some cause and effect. These systems really need to interoperate with one another. The challenge we have, or most of our sort of customers have these days, is that when you start looking to integrate all of these systems, it becomes quite complex because there's various levels of integration. The first level of integration is network integration. By this I mean making sure all the systems are on the same backbone, same network. Then that would allow you to look at sort of data mapping, because all of these systems talk different protocols, different data formats, and in order to get these to interoperate, data needs to be mapped with each of those systems. And then beyond that, the third level of integration is around developing sort of applications, so to create some visibility and interoperability between those devices, and then finally getting that data into the cloud and do that sort of cloud sort of integration. With all of these sort of processes, the deeper you go into the integration, the more complex it becomes and the more costly it becomes. So this is why a lot of customers are sort of mindful and fearful of this, and tend to shy away through the cost and complexity. So what we did is we created what we call our independent data layer, or IAP. IAP stands for the IoT Access Protocol. We created this and developed this to allow the integration of lots of different devices from different data sets to communicate with one another. Now, IoT is something that we created, but it has been sort of published as an open standard and is freely available to anyone through ANSI or CTA 709.10. It's currently going through the European standardization as well as we speak. So let me talk a little bit about what IAP is. So basically, IAP allows you to sort of ingest various protocols that you typically find in buildings, and typically we come across protocols like BACnet, LonWorks, LoRaWAN, Modbus, and Ocean. And also there's third-party other protocols that we give you the ability to create some custom sort of interfaces. So you have the associated protocol drivers that come into sort of IAP. And the first step, what IAP does is then it does what we call our data abstraction. So by this I mean it takes all of those different data forms, data sets from various different protocols, and then normalizes that data. By that I mean every data point is then structured in a common format. So a BACnet data point will look exactly the same as a Modbus data point, and a LON data point, and an Ocean data point. And then once that data abstraction has been done, we can then look at the informational model of that data set. So each data point will have a certain amount of information behind that. So we make sure that everything, once it's been normalized, is got the right kind of information model for us to then be able to create and add a number of services. For example, once you've got all of that data, we're going to look at creating some data logging and trending. So we need to know whether, if it's a temperature value, it's not just a physical number, it's temperature from a certain room and a certain space, whether it's indoor, whether it's outdoor, etc. So then we can create out of the various sort of trends and logs of that data. And essentially, we also have the ability to now take that data and push that data to various applications or clients. And these could be backnet clients like a building management system. It could be in the industrial world, it could be a SCADA system, and we can do that via sort of OPC UA, or we can connect to the cloud through MQTT or other open-based APIs like REST or WebSockets. And this allows you to then run some additional services around scheduling and alarming. So obviously what you want to know is all of that data. We want to know if that data is still staying within parameters, and if things go out of parameters, we can create some alarm priorities and alarm thresholds, so you can get notified if something is out of let's say the parameters or set points, as we like to call them. You can also create sort of schedules for your data, i.e. sort of daily, weekly, monthly, annually. IAP also allows you to manage those devices through the network. So essentially what you've done within IAP is create a digital twin or a virtual of that sort of data point or that device level. So then you can manage those devices and data points and monitor the sort of health. So you want to know if that device is still online, if it's still in with parameters, if there's any problems with it. So IAP allows you to do all of these things. And because IAP is an open standard, you have zero vendor lock-in. It provides you with a uniform data collection and abstraction service. It supports multi-protocol interoperability, and you have the ability to create custom applications and have custom application support. So what we did is we took IAP and we embedded it into what we call our smart server. So typically, if you look at a building and the typical sort of network architecture of the building, and this is at a very sort of high level, we've got our device level networks. So this is things like wireless sensors from different radio protocols. You've got energy meters. You have a whole host of IoT devices. So this allows you to get an understanding and granularity of what's happening within your building, within your space. All that data then comes into the smart server, where we do all that let's say data abstraction and normalization. And then we can do various things with that data. Now it's within our smart server. We can connect directly into the building automation systems, and I have to sort of just mention that this communication is bi-directional. So we can connect into HVAC systems, into lighting systems, into fire and life safety systems, etc. On the other hand, we can also have bi-directional communication at that management level network with regards to multiple user interfaces. So this multiple user interface might be your supervisory building management system, or it could be your SCADA system that is controlling and managing all those systems through a graphical user interface. So we have bi-directional communication to those systems. And then thirdly, we have the ability to connect via open APIs and open standards to applications that are running in the cloud, whether these are visualization applications, whether it's any sort of machine learning, AI, analytics type applications, and then it doesn't really matter which cloud infrastructure we can connect to. It's built through open standards. So whether it's AWS, whether it's Azure, whether it's Splunk, it doesn't really matter. We can connect to anybody's cloud infrastructure through open standards. As this device is connecting to lots of different devices, and we're in a world where security and IT security is a hot topic, we wanted to make sure that the smart server would meet the existing sort of requirements within cyber security. So it has a whole host of securities already built in. So it's secure by default. Its connections are through secure MQTT and HTTPS connections to the external clients and services. The smart server runs Ubuntu Linux 2004, so that supports the latest TLS 1.3 standards and 256-bit AES encryption across all its services. As the smart server is a Linux box, we have the ability to run third-party applications directly on the smart server. For example, some of our customers want to run their own VPN clients for that additional layer of security. We support cryptographic modules that support FIPS 140-2, which are in line with the federal guidelines. Authentication is done using sort of factory signed certificates or signed certificates from any sort of certificate authority. There's autonomous edge operations in case of loss of connectivity, so you will be notified if there's any connectivity issues. It's password protected at a user and role base, so you can define the user credentials, whether that's just a common user, whether it's an admin user, and those security elements are built within the smart server to give you sort of minimum password strength requirements. There's device authentication and encryption support built in, and recently we got approved for GSA. So GSA is the Government Services Administration in the US. So the GSA manage all US government buildings, and they have a certain level of security requirements, and the smart server is approved for use in government buildings and Department of Defense applications. In addition to this, we also work with a number of organizations within the sort of banking and the financial world who have very, very strict requirements around sort of security. So the smart server is a very sort of secure device in that aspect. Some example use cases that we could sort of work with. So you can create a building automation system for facilities with minimal control. This is typically for sort of smaller buildings where you wouldn't necessarily warrant a full-blown building management system. So we can use a smart server to connect to various devices, HVAC devices over IAP. These devices typically will speak sort of BACnet, and then putting a smart server onto the network will allow us to sort of communicate directly with those devices to create a certain level of automation and control within that system. So you can do sort of device discovery. You can create those connections. You can create the logs and the alarms to be able to monitor all these devices and log all of that data locally and pass that data up to either a server where you're doing your logging centrally or into the cloud. It also gives you the ability to integrate new technology into existing systems. So if you've already got a a system or a building with building management systems, and you have multiple buildings, we can take all of the data from existing buildings, integrate new technology. So a lot of buildings are now wanting to install some wireless devices, wireless sensors, etc., to get better granularity of how all of that, how all of their buildings are working across an estate. And we can use the smart server and IAP to collect all of that data, normalize that data, and manage that data across multiple buildings and push that data up into any cloud applications, so customers can then look at their estate from not just a building level, but an estate level as well. So it gives you a lot of sort of flexibility to be able to understand how your buildings are being used and where we can sort of gain any efficiencies through optimizations. So obviously that's the end of my presentations, and I guess we're going to open it up now to any questions, and we're more than happy answer any of the questions you may have. Thanks.
All right. So thank you, Cal, for the presentation. Also, Markus, thank you for the presentation. There's already some questions, so I would jump straight into it. I will start from the bottom one. Give me a second. I need to scroll down now. So there's a question. I did not know there about other webinars. Can you please send me the links to the recordings? This is obviously a question for me. Sure, we will provide everything afterwards. Also for the cellular series and also for the Wi-Fi series, you will be informed for this. Okay, then going further, I understand that light can be used for energy harvesting sensors, but what happens at night? Does the sensor still work or operate? Markus, I guess that's for you.
Yeah, correct. That's a very good question. Yes, indeed. This is, of course, what people ask us. It's maybe in the first moment, yeah, using light is something natural, let's put it this way. But of course, also here, the intelligence and the secret is that you store that energy. So that systems typically start operating at 200 lux, which is very little light. They just need a certain amount of time. We also provide in our documentation also some guidance. There's an application note. If you have that light for a couple of hours, that's enough to charge the supercap, which then gives you that autonomy to work at night. So this energy accumulated, depending on the sensor activity, gives you 3-4 days also to operate. And that's what is the important thing to know, that it's not only the energy harvesting, but also how you manage. And that's, to be honest, also one of our know-how. Power management, effectively power management, how you charge the system when there's little light, when there's more light, and how you operate it, and then give also and monitor this energy given to electronic part in order to make sure that it's operated reliably. Yeah.
Okay. Then going further, supercap manufacturers declare life of some years of their products. According to your experience, what is the life expected of a supercap based on energy harvesting, for example, a solar energy one?
Yeah, there's of course some calculations, but we ship these products into the market, or maybe as a practical, then there's of course also data, but then as a practical, we ship these products more than 10 years into the market, and we have not seen any returns from that regard. So of course there's a very thorough selection. I know also then that this is in our R&D team, not every supercap is used. So this has to do with impedance, it has to do with self-charging, with of course lifetime, and all these factors together. On the actual lifetime, I would not know honestly out of my head, but again, just from a practical perspective, I can confirm that these concepts and products we ship more than 10 years into the market with no problem or no returns, honestly.
Okay, sounds good. So, okay, the next one is for you. Smart server IoT. I know that it offers connectivity, network interfaces to the LoRa protocol. What about other network protocols or even wireless protocols?
All right, thanks, Thorsten. That's a great question. So yes, the smart server is a multi-protocol edge server. So yes, we support LON because that's our background, but we support BACnet. We support Modbus, Modbus, both flavors, RTU, which is the serial version, and then Modbus TCP, which is the IP version. We support Ocean, naturally. We also have built-in support for LoRaWAN, MQTT, OPCUA, and through the open interfaces, we have REST API, web services, WebSockets. What's also important to mention is that the Smart Server also has a built-in what we call our custom driver framework. So this allows any third party to develop their own drivers very, very easily, very, very sort of simply and very, very quickly using the driver framework. And that's available and openly available to anybody. All the documentation and the API documentation is available freely to anyone on our documentation portal.
Okay. Yes. Thank you. Next one. How is the N-Ocean Alliance related to the N-Ocean GmbH?
Okay, I guess that's for me again. Again, a very good question on this. Thanks to the audience. Yes, again, yes, I understand that there might be some confusion because, of course, both entities, let's call them, have the name N-Ocean. It was born like N-Ocean as GmbH. Like I said, have been founded 2001. A hard technology provider, develop, and supply components in order to allow OEMs to create their products using the N-Ocean radio protocol and also Bluetooth and Zigbee, of course. As mentioned before, the N-Ocean radio was invented 20 years ago in absence of any alternative, I must say, because at that time energy harvesting was at its first appearance, so no other protocol was suitable for that, and this is why the protocol was developed. But of course, in order to create acceptance into the market, you have to create this as an open standard. We have to heard this also with IAP in order to have no vendor lock-in. So this is why the N-Ocean Alliance has been founded. There was, I think, 5 or 6 member companies 15 years ago. And the decision at that point with the board, similar to any other alliance, was decided to take the name N-Ocean into the alliance world. But again, N-Ocean Alliance has its headquarters in the US, has a separate organization and separate structures, and we are member in the alliance. We are on the board, but everybody else can also join us aboard. Product manufacturers, Rutronik is member in the alliance as well, for example. And so this all together helps us to create this ecosystem, to create interoperability, and to create new products, especially for applications to come yet, and to create this choice of solution, which is very important in order to cover these projects.
Okay, thank you, Markus, for answering this question. The next one I think is also for you. So for the TCM 600, 615, the preliminary manual does not seem to have any details about firmware development, memory size, etc. Is this available? Also in the question, it's mentioned that the person is having experience with programming the TCM 310.
Yeah. So here it is. So there is a firmware. So the 615, for example, we have just released, I think, a week ago, a user manual that gives a little bit more description. But there's just, I think, to my understanding, a short section which interfaces to use on how to do that. I need to check because, of course, there is a possibility to do firmware upgrade. So if there is a need, then of course, best would be maybe to raise the question maybe to you, Torsten, and you pass it on to me so that we look into it. Because again, the question was raised and we have an initial description. But of course, if there's a specific question how to do it, then we would need to check. And again, it's the first revision of the user manual. And of course, every feedback is welcome, which we could add to the next edition of the user manual, where we, of course, would need to have such information. So yeah, indeed, I know that there's a limited section, but if there's more information needed, let us know, then we can work on it.
Okay, yeah. So thank you also for answering this question. So far, I don't see any further questions. So I will just do a quick outro. with some contact details where you can find us and so on. So overall, you can check our Rutronik 24 webpage. There you can also see the recordings of previously webinars. If you want to have some samples or whatever, if you're looking for some products, you can also check our Rutronik 24 webpage, our web shop. And if you're interested in some technical details, then you can always refer to our Rutronik Tech webinar. Also, we have our own newsletter and also placed in social media where we post frequently. Then, like I said, here are my contact information. So like I said, Thorsten Killinger with the email address and with the telephone number. So if you have anything, just call me or write me an mail. Or you can just scan the QR code and send your request via our Rutronik web page. And the last slide I want to show right now is what's coming next. So currently this week, this week, we are speaking about ultra-wideband, LoRa, and suitable or other technologies which are suited in there. So currently we have here at an Ocean. This is the only webinar for today. Yesterday we had Inside SIP and Infineon already. Recordings will be available soon. Tomorrow we will have Murata, where we talk about LoRa, and then also a little bit later that day we have Kyocera AVX in-house, where we also speak about ultra-wideband and low power WAN antennas. Then we, on the last day, we will have our partner Edge Impulse, who will speak a little bit about machine learning with Nordic Semiconductor, and also later that day we have Yageo in there as well with another antenna solutions. That's then all for this week. Then we have in 2 weeks, we have our highlight, which is the Bluetooth webinar series, where we will also have different suppliers in there and talk also about very interesting stuff. So keep it in mind, and yeah, let's see you there. And then that's all from my side. Markus, Kel, thank you for your presentation. Thank you for your participation. And I wish you all a good day.
Yeah, thank you, Thorsten, and thank you to Rutronik for hosting us on this webinar series, and then finally thank you to the audience for taking their time out to listen in. Hopefully it was of interest, and we're here to help if there's any further questions or you need any more information.
Yes, sure.
Thank you. Yeah.
All right. Thank you.
Thank you.
Have a good one. Bye-bye.
Yeah. Bye.
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 Thank you. Bye.